All right, so we know now that atoms can have multiple atomic mass, right? Any atoms can have multiple atomic mass, like carbon have like carbon. Normal carbon is 12. We have carbon 13, carbon 14, carbon 16, but very small amount. Neon, but now we're gonna just focus on the neon. Okay, so now we know that neon just one element, but have different masses, right? The question is, and the problem that we have right now is, if you look at the periodic table, neon has only one mass, right? Like pause the video and check look up the periodic table somewhere. Just look at any periodic table, right? How many mass of neons are there on the table? Just one. Now we have three masses. What are you gonna do? So which mass are we gonna put on the periodic table, right? So this atomic mass is not like a real mass. If you want to check the real mass in grams, so it's there. The neon 20 is at 19.9924 grams, right? The neon 21 is actually 20.9940. That's 21. That's 21. 22, so 21.9914. Okay. So these are actual mass of each neon. But which mass we're gonna put on the periodic table? But if you look at the periodic table, the mass of neon on the periodic table is none of this. No, it's none of this at all, right? But it's close to one of this. I think it's close to like the first neon, the 19. Okay, here's how we do it. We look at the percent abundance, which is how much they actually exist in nature, right? We found that neon 20 is about 90%. The neon 21 is 0.26%. Neon 22 is about 9 to 10%. And we use the average atomic mass. That mass, we put that on the periodic table. Okay. Now, here's how we do the average atomic mass. All right. So the average atomic mass, I just abbreviated, just add AAM. Yeah, average atomic mass. Okay. So some of you guys, if you have taken stat before, this is how we do average, right? If you haven't done that, don't worry, I'm gonna show you, okay? So we're gonna take the actual mass times percent abundance, right? So 19.9924 times 90 something percent, right? And then plus 20.9940 times 0.2696. They don't have a lot of it, so this number is gonna be real small because they don't have a lot of it to contribute, right? The 19.9924, there are a lot of it in the nature. So this guy will contribute to the average mass of the neon. And also the same thing, 21.9914 times 9.2465 right there. And the whole thing, this is percent, the whole thing is 100. I divided by 100, right? And if you do the calculation right here, so watch out there are too many numbers there. So watch out when you do the calculator. Is the average atomic mass is 20.1799. Okay, and we put this number into the periodic table. All right, and this number is gonna be close to the one that has highest percent abundance, because this guy contribute to the real, not the average atomic mass the most, because it's heavy. There are a lot of it, right? So just try to make it as a picture. So if some of you are visual learners, so right here, the average atomic mass depends on how many are there. We have tons of neon 20, small amount of neon 21, and just little amount of neon 22. So the average atomic mass is going to be slightly toward the one that have the highest number. Okay, so closer to the 20 AMU, and it's actually about 20 AMU. All right, so this number right here, the percent right here, 90.2, 9.2. Instead, the stat call them weighted factor. This is the weighted average, which is exactly the same with how we calculate your GPA. All right, the class that has one credit hour versus the class that have 4 credit hours. The 4 credit hours contribute more to your GPA. Like the overall GPA, right? Same thing there, same idea, okay? All right, we have concept test right here. So without calculation, no calculation right here, no calculator, okay? So bromine exists as 2 isotopes. We have bromine 79, bromine 81, okay? The average atomic mass of bromine is actually 79.90 AMU. Based on this number, which of the following is true about the isotopic distribution of the bromine? Nearly all bromine is bromine 79. Nearly all bromine is bromine 81. There's slightly more bromine 79 than bromine 81, and there's slightly more 81 than 79. All right, think about that. Pause the video or whatever. Just think about that. All right, without a calculator. Now, if you look at this number, oh no, hold on. Let's do this. So, there are two bromines, right? Two isotopes of bromine. So, bromine 79, bromine 81. Just if in nature, if they are the exact same amount of both isotopes, 50% 79, 50% 81 exists in nature, the average atomic mass of bromine is going to be right into the middle. Does it make sense to you? I'm saying one more time, all right? Just what if there are two isotopes of bromine, 79 and 81. Right? If in nature these two isotopes exist in the same amount, 50% and 50%, if you do the average atomic mass, it's gonna be right in the middle, the 80. Does it make sense? All right. But the average atomic mass of bromine in reality is 79.90, so it goes toward to the left right here. What does it mean? Who has more, 79 or 81? Slightly, 79 is slightly more than 81. That's how the average atomic mass works, or the weighted average works. Right? The 4 credits hour class have more effect to your GPA than the 1 credit hours class. Basically, that's what I'm saying. Right? So there are more of the bromine 79. So the average atomic mass gonna be go towards 79.9. Okay. All right, we got one more. All right, so this one just for your own calculation, so I don't have to explain anything. It just go back to the formula and just plug and chug. All right, so the average atomic mass, so there are two isotopes of chlorines. One is 34.9 blah 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 AMU, the other one 36.96 AMU. Okay, the first one have 75%, the second one have 24.22%. All right, do on your own and then check this with me. Just super simple there. So you take 1 AMU times its percent, the other atomic mass AMU times the percent divided by 100, and there you get that. Right? If you check the mass of chlorine on the periodic table, it's 35.45. Pretty close. All right. So we have chapter 3, class activity number 3. So this one you have to think a little. All right, have to think a little. If you get it right, the number is super simple: 90% and 10%. All right, I give you an answer right here. You have to do it on your own. Okay, I'm not telling you how to do it. If you can, let me know. I can go over this with you through Zoom or through email, whatever. I can check your calculation for you. Don't worry about it. As long as you can do it, that's good. That's the whole purpose of it. All right, so think about it a little. Okay. All right. That's I think that's that's the last. This is the last video of this chapter. I'll see you on chapter 4. Here we go.